definite and improper integrals, etc. So in the last class we have discussed the basics of formulas, standard integral formulas, which I provided on the board, along with the closing session, that is the last of the closing session, integration by parts also, that is general rule of integration by parts, UV rule. So now I am continuing standard procedures by using integration by parts UV rule, integral UV dx rule. The standard procedure means that is one step answer. Okay, 3 to 4 are there. So first I will write these 3 to 4, then I will give the meaning of definite integral, followed by application area, and followed by gate questions and properties, and then improper integral. Integral, first one, e to the power ax cos bx dx is equal to, so according to LIATE, logarithms, inverse, algebraic, trigonometric, exponential. So according to this sequence or order of these letters, whichever the first letter, that is first function, automatically the second function follows the second letter. So what is the sequence of letters? First is L, second is I, third is A, fourth is T, fifth is E. In the product of two given functions, first you identify the function corresponds to the 5 letters LIATE. So here L first, automatically that function is U. Suppose in one of the function is L, logarithm function, that is considered as fx, that is considered as U function, automatically the remaining function is V. Suppose sin inverse x into x, sin inverse x is inverse function, x is polynomial, that is algebraic function. So sin inverse is I letter, so I comes first in that product of two functions. So sin inverse x is U and the remaining function is V. So in that procedure you have to properly identify which is U function and which is V function, then go on applying that procedure. So here not required to mention U and V, because I told you already these are one step answers I am giving. Better to consider these standard integrations by parts as formulas. This is V function, exponential function. E to the power ax by a square plus b square into a cos bx plus b sin bx. This is using integration by parts. Using integration by parts, this is the answer, but I am not proving. I have considered these standard integration by parts examples as formulas. It is very much useful in this chapter as well as some other vector calculus, differential equations also, Laplace transforms. 2. E to the power ax into sin bx. As above, this is U function, this is V function. And don't think that first x term in the product of the given two x terms, first is always U, second is always V. Here first is exponential, but it is V letter. Here second function cos, but it is here U letter. So e to the power ax by a square plus b square into a sin bx minus b cos bx. And the third one is integral x to the power n ln x, natural logarithm x, is equal to x to the power n plus 1 divided by n plus 1 into log x minus 1 upon n plus 1, provided denominator not equal to 0, that is n not equal to minus 1. So you can write standard results. And sometimes after integration you should substitute upper limit, lower limit, that is definite integral definition. So there you have to remember some trigonometric sin 0, cos 0, sin pi, these formulas, and sometimes even function, odd function definitions. This is these definitions are the purpose of doing the given definite integrals in the easiest way. Note, or you can write formulas also. Sin n pi is equal to 0. Okay, that is n is any integer. n is equal to 0 plus or minus 1 plus or minus 2 etc. 2. Cos n pi is equal to minus 1 raised to n. N is equal to 0 plus or minus 1 plus or minus 2, that is n is any integer. 3. Sin pi by 2 plus 1, sin 3 pi by 2 minus 1, sin 5 pi by 2 plus 1, so on. Alternatively plus 1 minus 1. 4. Cos any number into pi by 2, n into pi by 2 is equal to 0 if n is odd integer. Okay, these are helpful in some integration problems. 5. A function f of x is said to be one even function if f of minus x equal to minus fx. 2. Odd function if f of minus x equal to, so this is first one is plus fx and this is minus f of x. So in the given function, replace x by minus x. Simplify. If you get minus fx, that function is odd. If you get plus fx, that function is even function. Okay. So standard examples I am writing. 1. Fx is equal to k constant mod x cos x cos hx x square even powers of x etc. are standard examples of even functions. 2. Fx is equal to sin x sin hx powers of odd numbers, odd powers of x etc. are standard examples of odd functions. E to the power x log x, they are neither odd functions nor even functions. And here odd into odd, this is very much useful whenever in integration or some other topics you have two product of two functions, odd into odd or even into even. So using this property, so you can save the time as well as steps also, especially in integration problems and definite integrals. Odd into odd, even into even is equal to even. Odd into even is equal to odd function. Odd plus or minus odd is equal to odd. Even plus or minus even is equal to even, where E is even function and O is odd function. And these are very much helpful in not only in this current chapter integrations, but also in Max 2, that is some problems that is in transform theory or Fourier series and some other problems, vector calculus. Wherever you have integrations with limits, these properties helps a lot. And the sixth definition, if f of x plus p is equal to f of x for all x, then fx is said to be periodic function. Sin x cos x are periodic function having period 2 pi, and p is the period of fx. The smallest of all such periods P first Ps is called the fundamental period. if exist. So what geometrically periodic function I told you in limits, beginning day of calculus chapter limits, that standard exam before limits, x minus square bracket x fractional part of x. Okay, so that is the graph of fx gets repeated after an interval of every length p. The graph of fx gets repeated after an interval of length p, every interval of length p, then p is called the period. And graph of even function is symmetrical about y-axis, graph of odd function is symmetrical about origin. That is also important. Graph of even function is symmetrical about y-axis. That means some functions through geometrically given, graph of fx is given between -1 to 1. Okay, so that fx is suppose x or x square. So what is the integral -1 to 1 -2 to 2 fx? Such type of problems graphically this point is useful. So even function, that is y is equal to x square, upward parabola is symmetrical about y-axis. Y is equal to x cube, that is cubical parabola, that is symmetrical about origin. In the last class, that at x equal to 0 it is a point of inflection, that graph. Okay, and graph of odd function is symmetrical about origin. Actually, symmetrical about y-axis means the graph whose area is equally lies in first quadrant, second quadrant, or third quadrant, fourth quadrant. Similarly, graph of odd function, that is if a function is odd, its graph whose lies equally in first comma third quadrants or second comma fourth quadrants, opposite quadrants. Okay, if a function fx is even, its graph lies equally area in first comma second quadrants or third comma fourth quadrants. Okay, so keep these points in mind. So they are very much useful in integrations or some other topics also, wherever you have derivatives integrations. So let me do some integration problems using by parts or without by parts also. Sorry, before that a small definition. After that we will start problems. Definition. If d by dx of some phi x is equal to fx, then that is integral f of x dx is equal to phi of x plus c. This is constant of integration. Then integral a to b f of x dx is equal to phi of b minus phi of a. Is called the definite integral. A is lower limit and B is upper limit. Phi of x is integral or antiderivative of small fx. So this is indefinite integral, this is definite integral. So this integration, that means the fx lies, we have considered a restriction that the curve lies between two vertical lines, x is equal to a and x is equal to b. So that integration value is definite. Okay. So that is obtained by original indefinite integral procedure, that is antiderivative is also called integral. After indefinite integral procedure, then substitute upper limit b in place of x minus, and then substitute in place of x lower limit. A is called lower limit, b is called upper limit. See, small example, integral 0 to 1 x cube dx. So this is your fx. What is x cube integration? In the last class I have provided x power n integration. X to the power n plus 1, 3 plus 1 by 3 plus 1, that is x to the power 4 by 4, 0 to 1. So this inside function is called phi of x. Now answer is phi of 1 minus phi of 0, where phi of x is x to the power 4 by 4. So that is 1 by 4 minus 0, that is 1 by 4. So definite value, that is why this is called definite integral. Note, first point, area bounded by the curve y is equal to fx, comma, x-axis and the lines, vertical lines, x is equal to a, comma, x is equal to b, is given by integral a to b fx dx. So area of a simple curve bounded between two vertical lines, that first vertical line is lower limit, the next vertical line is upper limit, and x-axis, that is nothing but geometrically the definite integral, integral a to b f of x dx. It represents to find area. So the diagram for this, some problems, if the question requires area, you need coordinate geometry knowledge. Okay, that is straight line equation, diagram, parabola and ellipse, hyperbola, circle. So just a curve. This curve I have taken as denoted by y is equal to fx. This curve lies between two x limits. Okay, two vertical lines. So this is a, this is b, and this is x-axis, this is origin, this is y-axis. So this line is x is equal to b. and this line is x is equal to a. The bounded area between curve x-axis and the two standing lines is denoted by some region area. So just shade this. The shaded region is called required area. Area A. Similarly, just in this point, interchange x and y, you will get area bounded by the curve x is equal to function of y, y-axis, and the lines y is equal to a, y is equal to b. That is nothing but integral a to b, f of y dy or x dy. So this is also called, just see, this f of x is also denoted by y because the curve equation is represented by y is equal to f of x. Second note point, this formula is related to, the procedure is related to area bounded by a single curve whose equation denoted by y is equal to fx. That means from the given curve equation, you should find y value in terms of x, then denoted by y is equal to fx, and find two x values which are nothing but lower limit, upper limit, and other bounded region, bounded curve is x-axis. Okay, so this is a bounded region area. Area bounded between two curves y is equal to fx, comma y is equal to gx, and the lines x is equal to a, comma x is equal to b is given by integral a to b fx minus gx dx, comma if fx greater than or equal to g of x. Okay, for every x belongs to the closed interval a comma b, where a is lower limit, b is upper limit. So geometrically, a rough sketch of the diagram of this point. This is origin, one upper curve, other is lower curve. So this is denoted by y is equal to fx upper curve, and the lower curve is y is g of x. Again bounded between two lines, vertical lines, small a, small b. This is area. Again region to be shaded by some red color. That shaded area is called required area bounded between two curves and the lines x equal to a, x equal to b. So this is x is equal to b, upper limit, and this is x is equal to a. Similarly, in this point, if you interchange x and y, then you will get the area bounded between two curves x is equal to function of y, comma x is equal to another function g of y, and the lines y is equal to a, comma y is equal to b. So depending on the curve equation, you should decide, or you should require whether expressing y is equal to in terms of x or x is equal to in terms of y. Suppose depending on the curve equation, if you get y is equal to in terms of x, then find two x values which are nothing but lower limit and upper limit of that area integration. Suppose if you have x is equal to in terms of y curve equation, then you need to get two y values, constant values. One is lower limit, other is upper limit. Then it is nothing but integration procedure only, area. problems. First one, this is asked in 2014 2 marks, 0 to pi x square cos x dx. 2. This is asked in 2013 2 marks, integral 1 to e root x into ln x, natural logarithm x, base c logarithms. 3. Which is asked in 2003, integral, indefinite integral, dx by e to the power x minus 1. And 4, integral minus 1 to 3, mod x minus 2 dx. So, now it is integration by parts. X square is algebraic polynomial function, cos x is trigonometric function. According to the 5 letters given in the last class, LIATE, algebraic is first and trigonometry is last. So, this is u function, this is v function. Now, what is the answer for integration by parts? U into v1 minus u dash into v2 plus u double dash into v3, etc. Where dash or primes stands for differentiation, suffixes stands for integration. So, x square into cos x integration, sin x minus u dash x square derivative to 2x into this sin x integration, that is v2 means second integration of v function. V function is cos first integration sin, next sin integration is minus cos x plus this 2x derivative, that is u double dash becomes 2, this minus cos x integration, that is nothing but third time of integration of v function. So, minus sin x and then limits 0 to pi. And I told you before these problems some trigonometry note points. Sin 0, 0, sin pi 0. So, this term vanished for lower and upper limit. Similarly, this term, this arrow is equal to 0 in my class, in my explanation means that which is vanished. Vanished means which becomes 0 for both limits, upper limit and lower limit. And we left with remaining term, middle term. So, minus 2 into minus plus 2. So, 2 into x cos x 0 to pi. So, 2 into pi into cos pi minus 0. Cos pi value minus 1. So, this value is minus 1. So, finally it is minus 2 pi. Now, this root x is nothing but x to the power half. So, again I gave standard integrations using by parts. N is equal to half, x to the power n into log x. So, x to the power half plus 1, n plus 1 divided by half plus 1 into ln x minus 1 by half plus 1. Okay. Since n is equal to half. Now, substituting upper and lower limit. So, this is equal to, first, this 3 by 2, I can write outside becomes 2 by 3. And then, x value first upper limit e to the power 3 by 2 into ln e value 1 minus, this is 1 by 3 by 2 is nothing but 2 by 3. So, before lower limit put minus and lower limit value 1, 1 power any number is 1. So, no use, 1 into ln 1 0 minus 2 by 3. So, 1 minus 2 by 3 value is 1 by 3. So, I can take 2 by 9, 1 by 3 common, e to the power 3 by 2 minus, minus and minus plus, here also 2 common, 1 by 3, and this 2 by 9 now becomes, so inside 2 is common, 1 is only common, 1 minus 2 by 3 is 1 by 3. So, I took as rigidly 1 by 3 outside. So, this becomes 2 by 3. Now this is a definite integral procedure. So what I am doing, in the last class I gave some formulas. You please check any formula is applicable. This is no use by parts. By parts is not useful. Okay, for this third problem. So last class formulas, standard integrals formulas. So what I am doing here, some extends in the denominator but no extends in the numerator. Okay, so generally methods of integration is using standard formulas integrations in the last class, or integration by parts today. Some example, first example, or substitution method, or partial fractions, or using f dash x by fx, integral f dash x by fx. So these are called methods of integration. Okay, so here what I am doing, I want to take e power x from the denominator outside, so that this becomes 1 minus e to the power minus x, numerator dx integral. Now shift, I want to shift this outside e power x into the numerator, which becomes e to the power minus x divided by 1 minus e to the power minus x. So 1 derivative 0, e to the power minus x derivative minus into e to the power minus x. So if I denote this denominator function fx, so numerator function now denoted by f dash x. Now it looks like integral f dash x by fx. So log fx. That means log 1 minus e to the power minus x plus c. So why I am adding plus c? Because it has no limits. So it is indefinite integral example. Now here we cannot integrate directly modulus function. So we have to eliminate modulus according to the mod x definition. Mod x is equal to plus x if x greater than 0. Mod x is equal to minus x if x less than or equal to 0. Okay, that time we discussed at beginning of calculus. So using that, in place of x we have x minus 2. So compare this x minus 2 with 2. I mean with 0. So x minus 2 is equal to 0 means x is equal to 2. So that number 2 is a between lower and upper limit. So in place of x mod x definition we have x minus 2. So we compare that mod x, each x with less than 0 greater than 0. So here also x minus 2 less than 0 greater than 0. That means you are getting x less than 2, x greater than 2. So the number 2, is it belongs to, is it lies between lower and upper limit or not? You please check the corresponding x value whether lies between the limits or not. Then you have to split the integral. That is called properties of integral. Break that integral, splitting the integral. So minus 1 to 2 mod x minus 2 dx plus integral 2 to 3 mod x minus 2. This is simple formula in definite integral properties actually. Integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. If a less than c less than b, whenever between the limits if you take a number c, then we can write that integral, definite integral accordingly, sum of two simpler integrals. Similarly whenever a to a limits are same, then answer is 0. Upper limit lower limit same, answer is 0. So between minus 1 to 2 randomly if you take any number 0 and if you substitute here which is a negative value, so minus of x minus 2 according to mod x definition, minus 1 to 2 plus between 2 to 3 take some random number, say 2.5, substitute here which is a positive quantity, so mod removes, so which gives same x minus 2 value, that is 2 to 3 x minus 2. This is just because mod x definition. Mod x is equal to x if x greater than or equal to 0, is equal to minus x if x less than 0. So this is a normal integration. Minus x integration x square by 2 plus 2 constant integration constant into x between the limits minus 1 to 2 plus this x integration x square by 2 minus 2 integration 2x 2 to 3. So later you simplify upper limit and lower limit. So here integral k dx, constant integration is constant into x. So k is constant. So this is minus 2 plus 4, upper limit value minus, substitute minus 1, that is minus 1 by 2, minus 2, and this is 3 square 9 by 2 minus 6, minus, substitute lower limit 2 minus 4. So later you simplify. So in this question I have done a silly mistake. Here 1 by 3 is common. I took already 1 by 3 common, so it's not 2 by 3 inside, it is just 2. So this is according to last example mod x definition. If that x minus 2 is positive, mod removes and which comes plus into x minus 2. If that x minus 2 is negative, mod eliminates, then it becomes minus of x minus 2 using this definition. And fifth example, which is asked in 2016, this is 0 to 0.9 dx by 1 minus x into 2 minus x. So this is according to partial fractions. So let 1 by 1 minus x into 2 minus x. So there are two types of factors in the denominator: linear first degree factors which are repeated or non-repeated, or quadratic factors. So proper fraction means, that is partial fraction means, it is a rational function where degree of the numerator less than degree of the denominator. For example, x plus 1 by x square plus 2. This is a rational fraction. Okay, proper rational fraction. So when denominator having more than one factor, linear or non-linear, so in such cases there is a procedure for partial fractions. Here both are linear factors, okay, distinct, different factors. So the corresponding partial fraction, this is 11th standard procedure. A by 1 minus x plus b by 2 minus x. On the right side, take LCM, a into 2 minus x plus b into 1 minus x. And this left side, right side, both denominators cancelled. After that it gives 1 is equal to a into 2 minus x plus b into 1 minus x. So then take x common here, minus a minus b into x and 2a plus b. So this one, equating like terms. We get minus a plus b is equal to 0, 2a plus b is equal to 1. Okay. So a is equal to minus 1 by 3, comma, b is equal to 1 by 3. B is equal to minus 1 by 3. So this b cancelled, minus a minus 3a is equal to minus 1, a is equal to plus 1 by 3. B is also plus 1 by 3. So come back to this, is equal to 0 to 0.9, 1 by 3 I can take outside because it is common. So 1 by 1 minus x plus 1 by 2 minus x. So 1 by x integration is log x. While integrating you should divide by x coefficient. So ln 1 minus x divided by minus 1 plus ln 2 minus x divided by minus 2. Limits between 0 to 0.9 pre-multiplied by 1 by 3. So in this 1 by 3, this is also minus 1, dividing by x coefficient is, in both x coefficient is minus 1. So I can use minus, take common, and a is equal to 1 by 3, b is equal to 1 by 3, 2a by 3, okay. Equating like terms, so kindly excuse me. Here no x quotient, so minus a minus b is equal to 0 and constant term is 2a plus b. So if I add a is equal to 1, solving, comma a is equal to 1, b is equal to minus 1, so 2 minus 1, okay. So now this is it's not 1 by 3, so a value 1, now this becomes minus, so 1 by 1 minus x integration ln 1 minus x dividing by x coefficient minus 1 and minus 1 by 2 minus x integration is ln 2 minus x divided by minus 1 limits 0 to 0.9. So this minus minus plus, using properties of logarithm, log m minus log n is log m by n, 2 minus x by 1 minus x limits 0 to 0.9. So if I put 0.9, so 1.1, if I put 0 minus log 2, so again using properties of logarithm, ln 1.1 by 2, 0.55. So this is the answer.